Hello, Year 8. It's forces, waves and generating electricity. We are on lesson 6. So let's have a look at some of these questions here. Question 1. What does acceleration mean? Well, acceleration means to me your speed is getting quicker. Question 2. What term means to slow down? Deceleration. Only one C in deceleration. Question 3. What does stationary mean? It means that you're not moving. Question 4. If the force from the engine is larger than friction forces, the car is going to speed up. It's going to accelerate. Question 5. If the horizontal forces surrounding a runner are balanced, they're equal but opposite. The runner will either be stationary, not moving, or they will be moving at a constant speed or a steady speed. Spring investigation. Springs can be compressed. You can see that in this diagram here, where their length is shortened by forces acting on it. They're the forces. Springs can also be extended by forces pulling them apart. Elastic bands and many other materials can be stretched. And if the stretching forces are removed, they are often able to return back to their original shape. They have the ability to store elastic potential energy. Stored elastic energy. You can clearly see here that this spring, when you add weights to it, it gets longer. And if you add more weights to it, it gets longer still. Okay, before we actually start the investigation, let's put down a success criteria. Write down one area in this investigation that you want to make sure that you are successful at, and explain why this might be useful. So it might be that you want to write down a detailed step-by-step method. Or it might be that you want to be able to identify the independent, dependent and control variables. It might be that you have a number link in your prediction. That would be a good one. It might be that you want to make sure that your results table has headings and units. It might be that you want to make sure that the line graph that we're going to generate is accurate and you've got correct scales and axes labels. Accurate plots and a good line of best fit. Now, why might this be useful to you? Well, when you decide on your success criteria, if you're able to do it, it's going to increase your level. It's going to help you in all subjects. It's a skill. Now, before we actually go on to the prediction and anything else, I'm actually going to show you a short video.
Wow. And there you go. Guess what as well? You're going to be doing the experiment. I was hoping you'd say that. Right, what do I need to do? Well, first things first, we need to wear goggles when doing this experiment because the spring has been known to go flying sometimes, so it's really important that we protect our eyes. Alright, the goggles are on. So it's a case of don't try this at home. Yeah, definitely not. I wouldn't do this unless under supervision. Alright, what's next? What we do? So here we have a hanging spring. And what you're going to do is you're going to add mass to the spring and measure how far the spring stretches. The spring stretches because the force is acting on it. Right, so if I'm doing all the hard work over here and the heavy lifting, what are you doing? Well, I've got a graph to plot, Gavin, and I'm also going to put the results that you give me into the table and then plot these points across here. So when you put on a mass, you're going to need to tell me how long the spring is stretched to, and then I'll take that away from the start length and plot the extension of the spring onto the graph. All right? So first, I need you to tell me how long the spring is now with nothing attached to it.
Right now, it is at 2 centimetres.
Brilliant. So I'll add that into here, and that is our starting point. So obviously the extension is 0 centimetres.
Yeah.
So now, Gethin, can you add one of the masses to the spring?
Add that on. And that goes down, and that is... Why is it called a mass and not a weight?
So it's actually the force is called the weight. So masses are pulled down by the gravitational field strength of the Earth.
This is 6 centimetres now.
Excellent. So I'll just put that into here on our spring length of 6. So if I take 2 away from 6, I have an extension of 4. And if I just plot that onto our graph here, so we have a point there. All right, okay, next one. Excellent. So yeah, add another one for me, please.
And this time it is 10 centimetres.
10. Excellent. So if I add that to our spring length, if we take 2 away from 10, we have an extension there of 8 from our original spring length. So if I plot that into here, 2 newtons and 8 centimetres. So our third one now, please.
Third one goes on there, and that is 14 centimetres.
Excellent. So 14. 2 away from 14 gives an extension of 12. So if I plot that onto here, we've got 3 and 12. So we've got 3 points on there now, Gethin. Can you tell me what that pattern looks like?
It's a straight line, isn't it?
Excellent, it is. And that is...
So let's write up our prediction now. Now we're going to use 2 terms here, the weight force in Newton and the extension of the spring in centimetres. Now, I think you'd agree with me that one prediction could be that as we increase the weight force, the extension of the spring in centimetres will also increase. But we can do better than that. We could actually put a number link in here. I think a better prediction would be if we double the weight force in newtons, then the extension of the spring in centimetres will also double. Now, let's move on to the apparatus list. We've got a spring, a clamp stand, 100-gram mass, which equals 1 newton of weight force downwards. That helps to cause the extension of the spring. And we've also got a ruler as well. Now, you're going to notice that I'm going to use all of these terms in the method. Here's an example of the method that you may want to use. Take a spring. Using a ruler, measure the length of the spring. Then attach the spring to a clamp stand. Take a 1 Newton force mass that is 100 grams and attach the weight to the spring. The spring will extend. Using the ruler, measure the new length of the spring. Take this new length away from the original length of the spring in order to work out the spring extension. Repeat this experiment with 2 masses, 3 masses, 4 masses, and 5 masses. There is a hazard. The spring might fly off the clamp stand. to reduce this hazard, wear goggles to protect your eyes. Can you identify the independent? That's the variable that we change. The dependent variable, that's the one that we measure. And 2 control variables. These are variables that we must keep the same in order to make the results valid and fair. So here are your 4 options. We've got room temperature in degrees C. We've got the weight force in newtons. We've got the spring extension in centimeters and the type of spring. These 4 need to be placed next to the correct variable. Now, the final thing in this lesson is I'd like you to use a ruler, and I want you to measure the length of this spring from this point here to this point here in centimeters. You can pause the video now because I'm actually going to put the right answer in. And the answer that I got was 4.3 centimeters. I wonder if you got that. Anyway, that's the end of lesson 6. We'll complete this investigation in the next lesson.